In this video, we're going to go over your guys' ELISA test, which stands for Enzyme-Linked Immunosorbent Assay. And as you can see, the purpose is to detect the presence and amount of an antigen or antibody in a sample. When looking at an antigen, the most common that you're going to see is those of a pregnancy test, which looks for the presence of HCG, or if it's looking for the time of ovulation, which detects LH. The most common form when we're going to use an antibody version is when we're going to detect something in the terms of viruses such as HIV or West Nile. And the antibody version is the one that is very, very specific when we're looking at the comparison between the two. The three most common types of ELISA that you'll see are called direct, indirect, and sandwich. I'm not sure which one you guys are going to be using for your labs itself, but I'll go over all three just in case, and then you guys reference the ones that you guys need for your class. First, let's look at the direct ELISA, in which the antibody binds directly to the antigen of interest. So here, the first step that we're going to have to do is simply add our antigen . And what we're going to do is we're going to let it sit for a little bit and allow it to stick to the wall. If we have our solution, let's just say all these dots are different antigens from that solution. However, let's say that our antigen of interest is going to be this pink one that I'm drawing in right now. Just know that in between each step, you're going to want to empty out the wells. So I'm not going to write it in just to save some space, but just know in between each step that you're going to want to empty out the wells, because you don't want the antibodies or the antigens binding in the free solution. You want them to kind of bind to the ones that have already bounded to the walls. So we'll go ahead and empty out the well, and then next we're going to add a blocking agent. Now, the question that I have for you guys is, why do we add a blocking agent? So I'll tell you what a blocking agent does. It kind of just fills up the holes in between all the antigens against the wall. But I want you guys to tell me why it is important that we have a blocking agent. Next, we're going to add the antibody. Again, after we've emptied out the well, we will then add the antibody. So remember that antibody is going to be specific for that antigen. After we add the antibody, we're going to go ahead and empty out the wells. We're then going to go ahead and do a wash. But please tell me, what is the purpose of the wash? After we do the wash, we're going to go ahead and empty out the well again. And now we're going to see if there's a change in color. And that Greek sign there, delta, stands for change in. Now the change in color comes simply from these little add-ons to the antibodies that will change color or fluorescent if the antigen of interest is present and if that antibody attaches to that specific antigen. Some of the advantages of the direct ELISA, as I said before, is that the antibody binds directly to the antigen. However, it also has less steps than the other two that we'll look at, and it is also a faster process. Continuing on to our indirect ELISA, we have an increase of sensitivity, which means that we're going to use multiple antibodies to bind, which from a cost saving perspective is beneficial because we have to buy less of that labeled antibody, which is going to cost more than just say regular antibodies that will bind to any antigen. As you can see, we've already gone through steps 1 and 2, which is adding the antigen, emptying out the wells, and adding the blocking agent. Here we're still going to be looking at those pink dots, but step 3 is going to be a little different, where we're going to first add in a primary antibody before adding in our secondary antibody. And what this essentially means is that the primary antibody is going to be the one that sticks to our antigen. So that's going to be step 3. Step 4, the secondary antibody, is going to be that labeled antibody. And what I was saying before is that we need less of it is because we don't need to use that much, because all we want is that color change. So if we use less of that secondary antibody, we can still get a color change simply because some of that secondary antibody attached to that primary antibody. And what that looks like is once the secondary antibody binds to the primary antibody, it causes the color change to occur. After that, it's pretty much the same thing, where step 5 is going to be a wash, and step 6 is just going to be the observation of that color change after the wash. The last ELISA test that we're going to go over is called the sandwich. And the advantages for this one, as you can see, is that the antigen solution does not need to be purified. The previous 2 ELISA tests were somewhat purified in respect to the antigen had to stick to the wells. So if we had, say, all the purple antigens sticking to the wells and none of the pink ones, which were ours of interest, if all the purple ones were to stick to the wells and prevented the pink ones from sticking to the wells, then we would have no color change. So in some regard, those antigen solutions had to go through some sort of purification step. It doesn't need to be perfect, but it has to somewhat filter out the antigens that we're not interested in. Here we don't have to do that, and this is very, very specific. So that's the advantage of the sandwich. It's going to be a little bit different, where the first thing that we're going to actually add is the antibody. And this is called the capture antibody. Where the antibody will be the one, where the capture antibody will be the one to stick to the wells. Step 2 will be to add the blocking agent. And it's the same thing where we go ahead and fill in all of these gaps. Step 3 is actually the addition of the antigen. So we're still going to go ahead and use our pink antigen. Step 4 is adding the primary antibody. which in turn also has the substrate on it. And if it binds, we will see a change in color after we do the wash. And as I said before, is if it is present, then we will observe a color change. So to kind of wrap things up, the three ELISAs that are most common are going to be your direct, indirect, and sandwich. We went over the benefits of each one and how they differ. And remember, ELISA is just a test simply to detect the presence and amount of any given antibody or antigen in a solution. So I don't know which one you guys are doing for your labs. It can change from time to time. If you guys are doing a different one, please let me know so I can make a video on that one. But if you guys have any questions, feel free to email me, and I will talk to you guys soon.